Hi there. Welcome to another edition of the YugabyteDB Tech Talk series. My name is Sid Choudhury, and today I'm going to walk you through linear scalability in YSQL, which is YugabyteDB's PostgreSQL compatible API. Let's dive right in. First, a brief intro about YugabyteDB. YugabyteDB is a transactional planet-scale database for high-performance cloud services. What does it actually mean? It means that we have purpose-built it ground up for modern cloud-native infrastructure deployments with support for both NoSQL and SQL APIs. Here is how the architecture of YugabyteDB actually looks. At the top half, we have three APIs that are wire compatible with existing popular databases. First is YSQL, which is Cassandra compatible, Redis, which is Redis compatible, and YSQL, the focus of our talk today, which is PostgreSQL compatible. Underneath all the three API layers is a common distributed storage and replication architecture that is built on top of DocDB as the storage engine, Raft-based replication as the primary replication mechanism, as well as a global transaction manager for handling distributed transactions. The key question is why even develop another SQL, or why develop YugabyteDB SQL? There are a few reasons. First is the support for the ability to do scale out in an SQL language. You can add nodes. That's what we're going to look at the talk today. And throughput can be, both write and read throughput can be scaled out linearly. You can deploy it across multiple regions in a globally consistent replicated manner so that you have zero data loss in presence of geographic disasters, as well as low latency for your end users. With that as the introduction, I want to walk you through a linear scalability demo that's right there on our doc site. So you would go to docs.yugabytedb.com and hit the explore section, because today we're going to focus on exploring some of the aspects of our PostgreSQL implementation. Go into PostgreSQL and then go into the linear scalability, and this is the direct link to that. Now I have a Mac here, so I have actually downloaded and installed the YugabyteDB software on my Mac. I'm going to start simply following the instructions that are listed here in the macOS tab. So first, we'll destroy any previous clusters that may be running. Okay, no clusters were running. Now what we'll do is let's instantiate a new YugabyteDB cluster with 4 shards per T server and with Postgres enabled. We'll see why both of these aspects are important. So there you go. We are starting up a new YugabyteDB 3-node YugabyteDB cluster with Postgres enabled in there. It is now up and running. What we can do is we can go and look at the localhost 7000 on our browser, and we can see the cluster configuration shown to us on the UI. Right now, it is set up with replication factor 3 and 3 nodes to actually host the PostgreSQL data or YSQL data. But currently, there are no tables in the system. So that's what we're going to do. We are going to get this sample apps from our sample apps repo. So there you go, sample apps is here. Now I'm going to start a PostgreSQL workload that is doing a bunch of SQL inserts and some reads. Now I'm going to start the workload. I'm just going to copy the Java command and start the workload here. So what this workload is going to do is first create a table and then start doing a bunch of key value inserts, and then start also reading the same information on a different thread. So Now we can see that the sample app is live. It's actually loading data into the system. What we can do is go back to our the YugabyteDB master UI, and you can see the number of user table has now become 1. So what we're going to go look at the IOPS per node. So let's go to the tablet servers UI, and we can see that there are 3 nodes in the system. They have 4 leaders each, and total number of tablets is 12. And now actually both of all these nodes are taking both reads and writes from the sample app we're running. So that's great. So now it's actually very simple. All we're going to do is go in there and add a new node to the system. So here is where we are. We'll add a new node. A new T server has been added to the system, and if we go in here and we refresh this page, we see that the 127004 new node has just come by, and it is already starting to take over some of the leader tablets and some of the follower tablets. And it's for the leader tablets that it has already received, it is starting to take writes, and for all the tablets that it has now, it is starting to serve reads. That's what we mean by linear scalability, because the total throughput of the system has now been increased linearly by simply adding a node to the system. So with that, we can, and slowly what we'll observe is that all the leader tablets and the total number of tablets will get evenly balanced among all the nodes of the cluster. This is because we want to ensure that each node is contributing uniformly or equally its fair share to the overall cluster's read throughput as well as write throughput. Very important in building large scale, evenly distributed systems. Now, scale out is good, but scale in is also important, because today's enterprises want to completely dynamically scale out and scale in on a need basis, and probably do it multiple times even during the day, depending on when they are seeing most users on their application. So all we're going to do is remove the node that we just added, and that's the command, remove node 4, and it is stopping the T server. If we go back to the UI, we'll see that the time since heartbeat for the 4th node is starting to increase, because that node is no longer heartbeating to the masters, which is where this UI is being created for us to understand the behavior of the system. Now, what's going to happen is the master is going to wait for 60 seconds before marking this node as dead. And at that point of time, the master is going to start recreating the lost tablets, both the leaders and the replicas, in the remaining 3 nodes of the system. So the system goes back to the old state where the total number of tablets in each node was 12, and the number of leader tablets on each node was 4. So let's see, it's 58.6. And now we will be at 60 seconds, and we cross the 60 seconds threshold, and you can see that the masters have marked the 4th node as dead, and very soon we'll see the lost tablets. You can see the lost leader tablets have already moved on to the existing nodes, and the total number of tablets will also be added to the system by the masters. Now, what's going to happen is at the 5-minute mark, which is 300 seconds, the master will take this dead node out of the quorum altogether, and as if it never had existed in the system. So with that, we have reached the end of our linear scalability demo. As you can see, you can just simply add nodes, remove nodes at will in an operational database system, and get the benefit of linear scaling and completely on-demand throughput. Now, all the things that I showed you today, you can try it on your own laptop. Go to this page, which I had used to show the demo to you. With that, thank you, and look forward to seeing you in the next edition of YugabyteDB Tech Talk series.